another one. So this problem, we're given x cubed plus 3x squared minus 14x minus 20 equals 0. Oh, I'm sorry, this is number 2 on the sheet. Okay, so this one's going to be a bit of a challenge. So the first one we did, we looked at it and we said, hey, we recognize we could treat this using the quadratic formula or using our difference of squares. So we saw a special pattern there. Here we don't see that. We have 4 terms. And here, so our first test, yeah, can we factor like a quadratic or any other special pattern? Can we factor out a greatest common factor? Can't do that. We're not going to be able to do that with a constant term at the end. I mean, typically, if we're able to factor out a greatest common factor, it'll be like maybe we're just given this and we're able to take out an x. Those are the kind of problems you'll likely see, but we can't do that here. We can't factor out the greatest common factor. Third, we'd go to look, well, can we factor it by grouping? At a glance, it doesn't look like we could look at factor by grouping, but to test that, you're just, and you may have to rearrange sometimes, I don't know, but we'll walk through this one. If I were to, let me not put parentheses here because I don't want this sign to change. But this is a group and this is a group. So I would look into the group and think, oh, well, what's the greatest common factor here? X squared. These both have at least an x squared. That would come out the parentheses. X squared times x gives me x cubed. X squared times 3 gives me back my 3x squared. And then what's the greatest factor, common factor here? Just 2. Or negative 2 even. So minus 2, I'm left with 7x minus 10. And when you're factoring by grouping, you're doing that so you could literally take out a factor. You would want these 2 factors to be the same. So you'd be able to rewrite it as the sum of this factor and these 2 terms in a single factor. But that's not the case here. We can't factor this one by grouping either because, yeah, even if we were to rearrange it and maybe test it with the 3 over here, the 14 over here, it's not going to give us 2 terms that are like, or I'm sorry, 2 factors that are like that we could factor out. So we can't factor by grouping. And these are the 3 ways you want to look at it first. Like, can I apply any of these methods? Unfortunately, in this case, we cannot. So now we have to hop to our rational roots theorem here. So I'll walk you through that a bit on this one. And it's something I think my students should understand and know, but I feel like in your coursework, you'll likely be able to use a scientific calculator to find at least one real root. And then it'll be to a point where now you're able to use one of these methods. But since we can't do that here, the 4th thing we would look to is, hey, can I use my rational roots test? Rational roots test. And what that is saying, so this polynomial is written here. How do we have them written? So in its standard form, but you guys are probably seeing it in your text. Where this function equals a n a to the n plus a n minus 1 times x to the n minus 1 dot 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 plus a1x plus ao. So I just wrote it down here because I got these notes for you guys over there. But this is it, the standard form of your polynomial. Polynomial. And it's just the variable way with all these terms to tell you that this is an, your leading coefficient, and this is ao, your constant term. And we need to know that for our rational roots test, because your rational roots test says that here they'll call P, they'll normally call the P the factors of AO, and they'll call Q the factors of AN. And your rational roots test will say that P over Q, all the factors, so any factor of AO over your factors of Q plus or minus equals, yeah, the plus or minus factors of AO over the plus or minus factors of AN. So P is just used to represent each of those factors. Q is used to represent each of those factors. So again, I think you'll see it presented in your text this way, which can be a little confusing, but that's what it's saying. So we'll look at these factors of 20. What are factors of 20? 20, and we have the plus or minus 20. And 1, plus or minus 1. 10, plus or minus 10, plus or minus 2. And what, 5 times 4? So plus or minus 5, and plus or minus 4. These are all the factors of AO. All the factors of negative 20. Plus or minus values of each. And then all the factors of Q, or Q, which are the factors of AN. So AN is just 1. We didn't have a coefficient. Again, AN refers to your leading coefficient. So we just have plus or minus 1. So we could have positive 20 over positive 1. And negative 20 over negative 1. We'd have positive 1 over negative 1. And negative 1 over negative 1. Well, we go through each one. These are all the possible roots. We have positive 10 over positive 1. Negative 10 over, am I missing something? Hold on. Let me rewind. So positive 20 over positive 1. Negative 20 over negative 1. These are the same. These will both give you positive 20. Sorry, I overlooked the signs for a second. But then we could also have negative 20. If just one of them was negative 20 over positive 1. And we already did negative 20 over negative 1. So here we'll have positive 20, we'll have negative 20, we'll have positive 1, we have -1, so +10, -10, +2, -2, and +5, -5, +4, -4. So I just broke this out. So these are all the possible roots. And I think this is as far as you typically may go in your coursework. Because again, this is what you would do if we can't factor using any of these other methods. But if we can't do any of those, we're going to look at the graph. We're gonna use a graphing calculator and find one of the real roots, and then that'll make it a lot easier to factor. But this is your rational roots test. So if you come up to where you can't use your calculator to find one root, or you're specifically instructed to use your rational roots test to find all possible roots, this is the method you would go. For this one, we were just told to find the roots. Let's see, what was the instruction? Specifically, they said, state the number of complex roots, the possible number of real and imaginary roots, the possible number of positive and negative roots, and the possible rational roots for each equation, then find all roots. Okay, so they wanted us to just go a different route. I just wanted to be able to walk you through how to solve this problem. But nonetheless, this was given, and we realized we couldn't do any of these methods, so we hopped to using our rational roots theorem. And for our rational roots theorem, we're looking at the leading coefficient and its constant, and the constant term of the polynomial, all their factors, and the sum, or the factors of your constant term go over the factors of your leading term. And that gives you all the possible rational roots. From here, we would test each one. We would test each one to see which term is actually a factor for this polynomial if you didn't have a calculator. I have an answer sheet, and I know that at least -5 is a real root. And again, we could graph that, and I'll show you how we get that. But -5 is a real root. But if you had to do this by hand, you would go through and test one, -1. You may just want to start with the smallest number, 2, then -2, 4, then -4, and then you would have gotten to 5 and -5. And the reason why I think you guys may not do much of this in your class is because, yeah, that's a lot of testing. Now let me show you the test. But this is how you get these roots. You use your rational roots theorem to get all these roots from the coefficient, from the leading coefficient and the constant term. So have that down for your notes. Okay, and let's get into how we would have tested these roots. Okay, so we're continuing with basically the second half of what we need to do using our rational roots theorem. So we skipped straight to say, okay, well, let's go ahead and test x equals -5. This was one of the rational roots we found. And here, let me quickly show you how you would get this from your graphing calculator. So here we have got x cubed plus 3x squared minus 14x minus 20. This is the polynomial that was given. And these are the 3 roots. These 2 roots that are real because they actually cross the x-axis, they are real roots, but they are irrational. Our rational roots test is going to give us any whole numbers or any nice clean fractions. These must be some funky numbers. So we'll see how we get to this. But your whole numbers, or like if we saw 0.75 or 0.5. We know we can express that as a fraction. 1.236. What will it even? It might. I think it might even just be rounding this value. This might be a much longer decimal, but we have 3 real roots, our whole number root, our fraction roots, our rational. I'm sorry. Yeah, these are our rational real roots. With the ones with the funky decimal or some crazy square root, these are real, but they are irrational. So from your graphing calculator, if you're able to skip the rational roots test, you would just get this one real root. And now we know, okay, we have x equals 5. So we have one real root. So here, let me stop off of this. Okay, so we have this one real root. And how would we have tested it if we went through -1, -2, 4 up to -5? This is the test. You're just dividing this factor. So here, this is, I'll show you the factor as well, because this, if we want this to say equals 0, we get x plus 5 equals 0. So this is the factor that will factor out. So when we go to divide it, you could use synthetic division, long division. I'm going to just run through it using synthetic division because I think that is the best method. I think it is the easiest. I would put 5 up in my box over here. I'm sorry, -5. I put the root, the actual root up in my box. And I'll take the leading coefficients of my polynomial. They are in descending order, the exponents, and are missing, so I don't have to worry about any place values. And they are 1, 3, -14, and -20. And we recall how to do our synthetic division, drop that first digit. We're adding this entire row. And we're multiplying what's in our box by what's below our line. So -5 times 1 is -5. Add it up. 3 plus -5, 3 minus 5, -2. -5 times -2, positive 10. -14 plus 10, -4. And then lastly, -5 times -4, positive 20. I have a 0 remainder. So once I got to the point where, okay, testing all those rational roots, oh, I got to -5 and I have a 0 remainder, boom, I know that x equals 5 is a real rational root for this polynomial. So that's the test we would have done to get to that point. But again, I don't think students are doing very much of that because you guys, typically we're gonna hop right to our calculator to find this real root, but that is how you do it by hand if you actually have to go through and test each root. Use your Rational Roots Theorem to identify the factors of your leading coefficient and your constant term, create that fraction, list out all the factors of each, and list out all those solutions and then go through and test it using synthetic division or long division. Here, so I'll summarize those steps because again, it can get confusing. So if we couldn't use any other method, 1, we do the rational roots test where we did factors of AO, the constant term, over factors of AN, our leading term, our leading coefficient. And then we found those solutions. So we listed out those solutions, I'm sorry, plus or minus, list out solutions. And then test those solutions using long division or synthetic. And not necessarily a step, but the solution with 0 remainder is a real root. So those are the steps you'll take if you can't go any other route. If you can't factor by grouping, if you can't factor by any special patterns or taking out a greatest common factor or using your quadratic formulas, we'll use our rational roots test. List out those factors of each term, list out those possible solutions, test each solution using synthetic division or long division, and whichever solution gives you a 0 remainder, that is your real root. So those are the steps you will take if you come across a problem where you can't use any other method. So yeah, I think it's important to really understand those steps. So have that down in your notes. And then we'll walk through and finish finding the other 2 roots for this problem. Okay, so let's finish this through. We've used our rational roots theorem to identify x equals -5 as one of the roots. Now that we know one root, we have a factor. And oh, you know what? I forgot to carry the solution from our long division over. So here, let's do that again real quick. So -5 up in our box, coefficients of our polynomial. Remember how to do this. Add this whole row, drop down your first term. What's in the box times what's below the line. Add that up. What's in the box times what's below the line. Add that up. -4. And what's in the box times what's below the line, +20. Okay, and then we had our 0 remainder. Or better yet, let me rewind and tell you what each of these numbers are exactly. So these are just the coefficients of your new polynomial. And you're starting with your terms 1 degree less than the polynomial you began with. So we started with x cubed. This polynomial will start with x squared, 1 degree less. And these are the coefficients of these terms. So this is 1x squared. We don't need to write the 1. This is -2x, 1 degree less. And this is -4. And we had that 0 remainder. So we're not ready to put that. But this is a factor because we divided the polynomial by x plus 5 to get this. So that's what we're doing here. We're dividing this polynomial by this factor to get this. And now we see, oh, we know how to factor this, right? We have a quadratic. That's a lot easier to factor now. So here, let's bring down this first factor. And how can we factor x squared minus 2x minus 4? Again, I look at the factors of this constant term. So I have -4. I only have 1 and 4 and 2 and 2. And which of these can give me -2? Oh, yep, not gonna play out as simple as we thought. You know, we can't factor this one this way because none of these will sum to give us this middle term. So we got to do extra work and hop to another method to solve quadratics. This doesn't factor easily. Yeah, we will want to use our quadratic formula. Because yes, -4, 1 and 4, that could only give us 3, 2 and 2, that could only give us not 2. So yeah, this and our solutions will be imaginary. So yeah, from here we have to use our quadratic formula. So here, let's rewind a bit. And sometimes you'll have to go through to do that test to think, oh, will this factor out nice and easy? Yeah, I got to try it and it doesn't. So just like we went through what methods can we use to make this polynomial simpler, we have to do that with our quadratics as well. What methods can we go through? So we can't factor it. Let's just hop right to the quadratic formula because that's going to work every time. And we remember that our quadratic formula, and we know our quadratic formula is x equals -b plus or minus square root b squared minus 4ac all over 2a. So yeah, when you're factoring quadratics, you know, if everything else fails, you have to go back to your quadratic formula. So, and that's where this is, the coefficient is a, this is b, and this is c. And we keep these signs attached to the term. So here, let's find out. What is our x? X equals -b, so -2, plus or minus square root of b squared, so -2 squared. Keep the negative with the sign. I think this is a common mistake. And depending on how you punch in your calculator, you may get an error. So -2 squared minus 4 times a. We don't have a coefficient here, so a is just 1. Times c, -4. And all of that is over 2a, 2 times 1. So yeah, just be very careful substituting your values into your quadratic formula. And I want you to be mindful of how you punch this in your calculator. I think at this point you could just punch it in your calculator. What's under this radical? Or no, let me not say that. But at this point, students, I think they often punch this in their calculator. And depending on how you punch this in, because -2 squared should give you +4. If you punched it in the wrong way, it'll give you -4. So just be mindful that of your solution here. So I think that I should encourage you to just do this work until it's simplified, and then we'll punch it in later. So from here, let's just get rid of these double negatives and simplify what we can. 2, it's -2, +2. Plus or minus square root -2 squared, +4. -4 times 1 times -4, plus 16. All over 2. And let's simplify that addition under the radical. 2 plus or minus root 20 over 2. And let's rewrite this as 2 factors. So 2 plus or minus root 5 times 4, because 4 has a perfect square root, and we're going to pull that out front. All right, let me continue down over here. So now we're at 2 plus or minus. Let's take the square root of the 4. Pull that out, and we're left with root 5 under the radical. All over 2. Okay, we could factor out a 2 from in the numerator. 2 times 1 plus root 5 all over 2. And now this 2 cancels. So this is still plus or minus here. 2 plus, here, 1 plus or minus root 5. And that's it. Yeah, those 2 cancels out. So we have 1 plus root 5 and 1 minus root 5. As our other 2 roots. So, and here, let's double check. 1 plus root 5, 1 minus root 5, and negative 5. Excellent. So we've got it. So what was the challenge with this? Yeah, once we had that root, once we figured out what this root was, and that gave us this factor from our synthetic division. Yeah, look, how are we going to further break down this quadratic? And we decided, okay, the quadratic formula is going to be the easiest way. And you could always go straight to your quadratic formula. Your other methods, again, they just may be quicker. But the quadratic formula is going to work every single time. It's foolproof. You don't have to worry about testing it, but it just can be a little lengthy if you don't have to use it. In this case, yeah, we had to use it. We wouldn't have gotten to the solution any other way. So yeah, take that all down for your notes. Did you get it? Were you confused anywhere? Try to walk through it another time on your own, everything from the start to how to do the rational roots test, to synthetic division to pull out a factor, and going the next step to further factor this using your quadratic formula.